Good morning and welcome to week 9 of our shutdown. And yay, our last statistical test. Now remember, this test, it's really short. I know it's 3 pages that I did it, but I wrote it all out and I did a bunch of extra stuff. But this test is going to be due Wednesday because it's really short. And then Wednesday, I'm going to start, I have 3 reviews for your final exam. So you're actually going to have something due Wednesday of this week and Friday of this week, sort of. But this is our last test, the RUNS test. Yeah, you can chuckle now. This is a test to determine if data is selected randomly. And you may see in the question, they may ask you to test for randomness. And your HO, which remember we always have equal signs here, data is selected randomly, or data and random are equal. That's your HO. Data is not selected randomly. Now you can't write these exact terms in your HO. You're going to have to be specific about what your data is. And your data is going to have to be either numbers, so that we have 2 groups, like even numbers and odd numbers. Today we're going to take a look at numbers and compare them. If you recall, at the beginning of the course, we were big on the mean. If something is normally distributed, then the mean is in the middle, and we work with mean and standard deviation. Now that we are working with non-parametric or non-normally distributed data, we're going to work with the median. So we might look at numbers. Are they above the median or below the median? We may look at genders, male and female, or 2 distinct groups. You know, you might want to do if you're Target or Walmart, if you are Nike or Adidas, but you have to have just 2 groups. And then a run is a consecutive group of like data values. So I have boys and girls, because that's kind of easy to do. So this first set of data looks like your 7th grade dance, with all the boys on one side, all the girls on this other side. So this does not look random to you. It looks like all the boys are on the left and all the girls are on the right. So all these boys represent 1 run, because they're all the same. All these girls represent 1 run. So there are 2 runs. You get a run of like values, and you get another run when those change. So when it changed from boy to girl, that was a 2nd run. N is 16, because there's 8 girls and 8 boys, but there's only 2 runs. And that's too few to be considered random. So that would not look random. This should not look random to you, because now they're boy, girl, boy, girl, boy, girl, boy, girl. And if you throw 16 people in a room, they're probably not going to stand boy, girl, boy, girl, boy, girl. There are still 16 people, but this time, because every time I have a boy, your first letter always represents a run. And then it switches. Every time it switches from boy to girl or girl to boy, it's another run. So because it switches every single time, there's 16 runs. 16 data changes from boy to girl, and that's too many. So to get data that is random, you're going to have something that's kind of in the middle. We don't want something like Goldilocks, too hot, this is too cold. We want something just right. And then your test statistic is simply going to be that number of runs. You look at your data, you identify the number of runs, and that's your test statistic. And then the critical value is going to come from a table. And here's the table. Now the table is only going to give you 1 alpha. So we are only going to do this test when the alpha equals 0.05. And this is going to be a 2-tailed test always, because it's either random or it's not random. It can't be greater than random. It can't be less than random. It either is or it isn't. And then they give you a little hint up here on how to determine if you reject or not. But on that last one we just did, you'll notice there were 8 girls and 8 boys. So whether you put girls here and boys here, or boys here and girls here, it never matters. So from 8 boys and 8 girls, you get this little interval. Remember, we had 2 runs, too small. We had 16 runs, too big. But if you have runs between 5 and 14, which means you have to have 6, 7, 8, 9, 10, 11, 12, or 13 runs, would be considered random. And then it says up here the opposite. It says you reject if the number is less than or equal to 5 or greater than or equal to 15. So you get a little interval. And then before I go back to my notes, here is the problem I did. This is 15. We have a school dentist wanted to test the claim, and there's our alpha equals 0.05, that the number of cavities in 4th grade students is random. 40 students were checked, and the number of cavities each had is shown here. Test for randomness of the values above or below the median. So the only thing I needed a calculator for is I put all these numbers in my calculator, and I found the median to be 2. And I feel bad for this kid that in 4th grade has 7 cavities. So my median is 2. I got to remember that number. And then I just put this data. You'll notice, here's my data. There's 1, 2, 3, 4 rows. And then there's 4 numbers in each column except for these last ones. But there's my 40 numbers. They're just going to look a little different on my paper because I kind of spread them out. So here, and I color-coded this to try to make it clearer. Here's my data. Here's my first row, my second row, my third row, my fourth row. So in pencil is my data. And then in red, I just put, because the median is 2, I put a B if it's below the median, I put an A if it's above the median. If you remember back when we did the sign test, we did, is it above the median, is it below, and we put pluses and minuses. It's up to you. Plus, minus, above, below, whatever you want. Now that worked until I got here. This is a 2, we don't count those. Just like in the sign test, we did not test numbers that were equal to the median. So these are all above, below, don't count. I put whatever letter is, don't count. That looks like a, let me fix that. That looks like a 4. That should really be an A. Above and below, and I crossed out all the 2s. And then in purple, I went back and counted my runs. So I have this B is my first run. And then this is where it switched. It switched from B to A, that's a second run. Back to B, these 2 A's, we don't count that 2, we pretend it's not even there. All those 3 A's are my 4th run. 5th run, 6th run. This is part of my 7th run, but there's another one below here. The 2's didn't count. So whether you put the 7 up here or down here, it doesn't matter, but these 2 B's are alike and they're 1 run, and that's your 7th. All of these A's here are my 8th run, 9th, 10th, 11th. This is my 12th because it went from B to A, 13, 14, 15, 16, 17. These 3 A's are all 18. I don't care where you put the 18. 19, 20, 21, and these don't count. So my test statistic is 21. I have 21 runs. Whatever that last number is becomes your test statistic. Now when you're doing these runs, make sure you go left to right first row, left to right second row, left to right third row. If you kind of serpentine your way through here, you might get a different number of runs. If you go up and down the columns, you might get a different number of runs. And mathematicians don't want 42 different answers for a question. So we like procedure. So you go left to right, just like you read a book, left to right, and you get your runs. And you cross out all those 2's. Here's my HO. Students, dentists checked for cavities selected randomly. Students not randomly selected. And then so that I can find my critical value, I counted up the number of A's, and you can count to check to make sure I'm right. I counted up the number of B's, and then I counted up the number of 2's. And then I made sure 18 and 13, that's 31, and 9 is 40, because I knew I had 40 kids. So if these numbers add up to the total number of kids, you're usually pretty good. But I think I checked those twice. And remember, read left to right. Okay, so the only thing you really need a calculator for, and we could have done this odd and even. Now, if you're checking numbers for odd and even, 0 is considered an even number because it's located between 1 and -1, which are odd numbers. So you could have done, these are even, odd, And all of these are odd. Ooh, I'm just looking at this right now, and that first row doesn't look random. So you can do them even and odd numbers. They may give you a number. They may not say use the median. They'll just say test for randomness and say, above or below some certain number. But it's usually a number in the middle, which makes sense. Now with that, 18 and 13, to get my critical value, I go back to that chart that I showed you. And here is the 13, and here is the 18, and the 18 and the 13, here's your interval, 10 to 22. Now, if you decide not to do 13 and 18, and you do 18 and 13, you'll notice that it doesn't matter. Here's your 18 and 13. It doesn't matter whether you go 18, 13 or 13, 18, that interval is gonna be the same. And it's gonna be, where's 13? Here's 13. It's gonna be 10 to 22. So that becomes 10 to 22, that's my critical value. Now remember my number of runs, and I'm gonna write it here one more time, my test statistic or number of runs was 21. I was gonna put equals, but I'll put 21 runs. And because 21 fits just barely right in that interval, it is a do not reject. And I just wrote again that alpha must be 0.05 because we don't have any other tables. So we do not reject HO. Now the question said to check for randomness. So you have there's no real claim, so you can write here, support the claim the number of students dentist checked were selected randomly. And you may want to put checked 4 cavities. I'm going to throw that in there because I probably should have said that. I'll put a little tweak and put 4 cavities. Or you could put cannot support the claim that the number of students dentist checked were not supported randomly, because it didn't say determine if it is random, determine if it's not random. It just said check for randomness. So that's kind of a little open-ended. So that's our last statistical test, the runs test. Now, by Wednesday, I'm going to want you to tell me I lost my page again. Gosh darn it. I'm going to have you try another one. I just want to take a quick look to see, because I want you to answer the often asked and always wondered question, which is better, Pepsi or Coke? So this one's a little bit easier because you won't have anything that you don't count. Everything is either going to be a P or a C, and you just go left to right. You don't have to determine above or below. It's just COLA orders. And you're going to determine right here, test for randomness, if these college corner cafe, if college students prefer. Is it random where they take Pepsi or Coke? Or is it not random and nobody takes Pepsi and everybody takes Coke, or the other way around? So you are going to hand in or send to me, please, by, see, I'm so used to putting Friday or Thursday that I'm going to put a Wednesday. Number 17. And you're going to say, is it... They don't actually say, because I don't know if you have to, it just says different brands. They don't want to come out and say Coke or Pepsi, because those are brand names, but I'm going to. Hey, what are they going to do to me? So you're just going to test the number of runs, Coke or Pepsi, and get that to me by Wednesday. And then just so you know, moving forward, Wednesday I will post a review for you. Now, there's 3 reviews. Each review has 2 questions on it. You don't have to hand me all the reviews, but I think I'm going to have you hand me just one. I'm not sure which one it is. But by Friday, I'm expecting that you should have the first review done. I'm not grading it. If you want to send it to me, great, and I will eventually show you the key. But this week, I need this test only. But I would like it would be helpful if you have all 3 reviews done before you take this final exam, so you can go back and look at the reviews for help. And then next week, there'll be a review I'll post Monday, there'll be a review I post Thursday, And on Friday, I will give you the keys to all the reviews. Now, the difference between the reviews is when I post them, I may tell you what they are, what tests they are. This is the Wilcoxon Rank Sum test. This is the RUNS test. This is the Spearman Rank. On the final exam, they will not tell you what tests they are, and you're going to have to kind of determine what they are. And I'll give you some hints on that next Friday when we go through them all. And then the following week, I'm going to, I think it's Memorial Day Monday, it might be. I don't know. But anyways, I'm going to post the exam on Monday. You need to give me the completed exam in Google Docs, or because it's going to be fairly long. I don't know if you want to take that many pictures. But you can do it in Google Docs and get it back to me by Friday. And then our course is done. So if you look on the website, the entire course is there. And then that last week, as you're doing the final exam, if you have any other stuff that you haven't handed in, some of those other courses, you can catch up on. Okay, I've talked long enough. It's Monday. Enjoy. Nice short runs test. And look Wednesday for that review that will open. Take care. Email me with questions, issues, cries of outrage, whatever you have. Bye.